Hey everyone, today we are introducing the visual analysis function in LiDAR360 MLS. First, we'll create a new project and select point cloud. If you have trajectory data, it's recommended to add it. Generally, visual analysis is done from observation points, so we recommend analyzing based on trajectories, and image data is optional. To access the visual analysis function, switch to display mode and go to the road feature module. There are two options, target and observation. The first feature, observation, refers to a fixed observation point that can be used to analyze whether a target within a defined range from the observation point is visible or obstructed. To perform this analysis, click on the observation button for visibility analysis from the observation point. Several options will appear on the right menu. First, select an observation point, such as a specific location on a particular floor of a building, and then draw a range box around it. For example, we might want to see where the features along the road from the building to a nearby auxiliary road are visible from this location. Double-click on this location to confirm the approximate area of observation. We can make fine adjustments using the parameter settings. The first option is direction angle, which allows us to adjust the exact position of the observation direction by dragging the slider. For example, we can adjust the position to be directly in front or slightly to the left or right. The second option is pitch angle, which can be used to adjust the angle of view. For example, we can adjust the angle to be level, slightly upward or slightly downward. The third option is view distance, which can be adjusted based on actual conditions, as the initial point may not be accurate. The last one is vertical field angle, which refers to the vertical angle of the viewing range. The fourth one is horizontal field angle, which adjusts the horizontal range. The vertical field range can adjust the vertical range, such as widening the entire analysis field of view vertically. Another one is sphere mode, which adjusts the diameter of a sphere centered at the observation point. However, frustum mode is more commonly used. After determining the viewing range, click Calculate. After the calculation is completed, if the points within the specified range from the observation point can be seen, they will be displayed as green points. If they cannot be seen, they will be displayed as red points. This makes analysis very convenient. For example, when analyzing a floor of a building, from the observation point, it can be used more extensively, such as determining the range of a street lamp's radiation, which areas can be illuminated and which areas cannot. Or, if the location of a light source is known, which floors will be affected by the lighting, especially for determining if the distance between buildings will affect the lighting on certain floors. This way, using the visible range analysis from the observation point will be very convenient. The second type of visual analysis is the visible area analysis from the target point. As the name suggests, it means that the target location has already been determined, and there may be trajectory or path. The question is whether the target point can be seen on this path. This analysis is often used in traffic, such as for drivers on the road, to determine whether traffic signs can be correctly seen and whether they are obstructed within the specified range of the driving path. This is crucial for the safety of drivers and passengers. Based on the point cloud map, we can perform a visible area analysis from the target point to determine whether the placement of road facilities is appropriate. We would select a target point from the data, such as a traffic sign, and then select the observation path. The observation path can be either the trajectory that has just been loaded or a vector line drawn in advance – using the map element module, or a custom vector line. Since the trajectory has already been loaded in the early stages of data, it may be more convenient to choose the trajectory for the analysis. This traffic sign may have a certain guiding effect on vehicles coming from this direction, so we will select the length we want to analyze by clicking and dragging on the trajectory. We can also turn on some category filters. If the point cloud has been classified in the early stage, this will eliminate the influence of noise in non-points. The parameter settings control the accuracy of visual analysis. For example, voxel size affects the precision of the calculation. The smaller the voxel size, the more accurate the result, but the longer the calculation time. Another parameter is the occlusion points threshold. When the calculated value is lower than 0.2, it is considered unobstructed. When it is between 0.2 and 0.8, there is some obstruction, but it is not severe. When it is greater than 0.8, it is considered severe obstruction. These thresholds can be adjusted according to specific needs. Clicking OK initiates the calculation, and the software will automatically generate visible nodes based on the trajectory step. The software will then draw virtual lines based on whether the nodes can see the sign. Green lines indicate an obstruction rate below 0.2, while white lines indicate an obstruction rate between 0.2 and 0.8. This makes it easy to determine whether a driver can see a sign while driving on the road. If a sign is not visible in a certain area where it should be, it may be obstructed or poorly placed. The results can be saved separately and loaded for future reference. This concludes the introduction of the two types of visual analysis functions. Thank you for watching.